I want to talk about automated testing tools. And I'm going to revisit a little bit of the territory that Lucas visited because like a lot of consultants and contractors that I talked to and myself at the jobs that I had as a developer, what I found a lot was that everybody can talk about testing and sometimes we give lip service to it, but we don't give it enough priority. And so for me, this is a really important piece of development. I want to make sure that I want to just recover this ground and just try to like drive home the importance of it. Because at the end of my talk, what I want is for all of you to go back to where you're at and make some positive changes in the overall quality of what you're doing. And automated testing is an important aspect of that. So why do we care about this? It's money. It's straight up money, right? It's the cost of what we're doing. Automated testing is all about the dollars. It's all about the Benjis, as they say. If we focus on automated testing, we will reduce the cost of what we're doing. Every dollar that we can put in is $2, $3, $4 that we will get out at the end, so long as we do things right. We can do things wrong and not get those kinds of returns, but we will get returns on automated testing that will come back to us. So let's talk about this a little bit, the cost of low-quality software. First off, we have the development costs of low-quality software. Does anybody here feel like the velocity of their team is lower than it could be due to the existing software that they've got, right? That happens. Anybody here know that there's some piece of code? This will get a bigger response out of developers, but even as leaders, you might have encountered this, that one piece of the software that people are afraid to touch. Do you guys have that? All right. Yeah, so that's a development cost that comes from low-quality software. There's other measurable costs. There's lost productivity. If people are spending time worrying about or fixing bugs, then they're not doing something else. There's lost sales. When our site is down or non-performant, we're going to lose sales. The studies, Aaron talked about this as well, the fact that if things take too long, then we lose sales or customers. I think there's some other people that touched on this as well. We can lose our sales because stuff isn't working right. The time it takes to clean up, if a bug goes in for a while, it can cause a lot of data issues. We have to go through and clean that up. So cleaning up, and that's just data. We could obviously have problems cleaning up other aspects. Then there's some immeasurable costs that come along from low-quality software. There's our confidence, the customer confidence, and our damage to our image, right? So I'll ask a question. This is a rhetorical question. Hopefully we'll all arrive to the same answer. What would you rather have your company be viewed like? Apple or Enron? Right? Like, there's an image matters, and it really matters when it comes to sales and the longevity and the vitality of your company. And that really matters, and the software is going to affect that significantly. Why does Apple have such a great image? Software is a big part of why they have the great image that they have. Lost opportunity. Again, we don't know what we could have produced because we were busy trying to fix a problem that we created. Resource misallocation. As people spend time and energy worrying about the problems in the software, they're not spending time and energy worrying about the features that could be going in, right? And finally, morale. Teams want to be proud of the products that they build. And you will have turnover issues as you have low-quality software. So those are all costs, future sales. This is one of those things that, again, it kind of relates to customer image. If you have problems with your software, you don't know what additional future business you could have received potentially that didn't come because of issues that happened due to bugs. Lucas talked a bunch about this, so I'm going to go really quickly through this. The cost of bugs increases the longer it takes for us to discover the bugs. So we have the repair costs. During design, our repair costs are nearly zero, right? During development, again, repair costs are nearly zero. The time it takes to, we discovered a bug, we have to make some change due to the defect that we found. During design and development, those costs are nearly zero. During integration, it's relatively low. We find during integration that we've got a problem, so it's not too big of a deal to go back and rework that. And during testing, which usually happens around the same time as integration or at the same time as integration, again, the costs are low. On staging, then it gets a little bit more moderate, right? We've already spent a lot of time to get something up on the staging, and now coming back and reworking it can take a little bit of extra time. And finally, in production, this gets really high. Sometimes this is due to just time. It's been a long time since we put something in, put our bug in. And sometimes it's because we've caused a huge problem now that it's been up on production. We have to make emergency measures, and there's all kinds of things that go on. I'm sure you're all familiar with the kinds of issues that happen when we have bugs that go into production. There's also the size of the risk that changes based on when we find our bugs. In the development to staging area, there's zero risk to having a defect in our software. Right? It doesn't cause any problem. But in production, the risk is high. It could not only cost us lost sales and business, theoretically, a bug could destroy an entire company. Right? The wrong things happens. Tell a little story from my own past, which is not about crashing a company, but I wrote some software, and I accidentally put something in a loop where we were communicating with a third party that charged us for every byte that we sent, and it went all night long, and it was just constantly sending data. So I got in the next day, and everybody's freaked out. They got this bill from the third party that was like 100 times what the normal monthly bill was, and these are the kinds of things that happen when we let defects get into production. So I want to talk one more thing. I want to frame my conversation about one more thing, which is called the grand theory of testability. You won't find this documented a ton of times, but this is kind of something that lives underneath the surface when you get into software engineering and the practice of testability. And that is that there is a high correlation between testable software and good software. Okay? That the quality of the software correlates directly to how testable it is. So therefore, how many tests that we have. Now, I'm going to be talking a little bit about the different types of tests, and I'm going to revisit this idea, but I want to introduce this here so you understand that the correlation between testable software and good quality software is very, very, very high. All right. Why do we care about automation tools? Because they make finding bugs cheaper. We want to find our bugs quicker and faster, and automation tools do that cheaper. When we have to employ a bunch of manual testing, or developers themselves have to find every defect, then the costs go up. If our developers are spending that time doing that, they're not spending time building software. Instead, we want to surface the defects effectively, cost-effectively, and automated tools allow us to do that. They allow us to surface these defects in a cost-effective manner. So let's talk about automated testing tools themselves and kind of get into the meat of what we want to talk about today. So there are several purposes to tools. I like to break those down into a few different areas. First off, some automated testing tools are about design. And those might be things that look at things called cyclomatic complexity, if you've ever heard of that term. They kind of detect how complex the code is. There are other types of tools that are about design. There are tools that are about correctness, and there's a high overlap between the two of these. A lot of times a tool is more about correctness. Does the test pass because the software will do this thing, and this given input produces given output? Those are correctness tools. Then we have performance tools. These tools are about, does it perform fast enough? Some of the stuff that Frosty was talking about earlier. So those are different purposes of the tools we have, and sometimes there's a little bit of overlap between areas, especially between design and correctness. But the tools produce these different purposes and allow us to look at 3 different aspects of our software. So when you are looking for automated testing tools, there's a lot of aspects that you should be considering when looking at these tools, when determining whether or not a tool is appropriate to be used for you in your team. I want to go through these in detail. First off is cost. There's a couple of ways that the tool has a cost to you. One is in license and usage, and some tools could be significantly expensive, and they might be outside of the range of your budget. So it's obviously important to know that. That one's easy. But the implementation cost is another cost that can actually be significantly higher, many orders of magnitude higher than the actual licensing cost, and that's how long does it take to actually implement the tool. So this is even more important than licensing costs, is to understand the implementation costs. And that's something you'll have to work with your team in order to get a better understanding of. Maybe do some testing of the implementation first in order to find out if the implementation costs are going to be unsuitably high, unacceptably high. Browser compatibility. This is an important one as well. Since we're here at Angular Colorado, I'm kind of going to be focusing a lot on web products here. So browser compatibility is very important. Are you testing all the browsers that you use? And even if there are browsers that you don't inherently support, it is still nice if tools will tell you if you have problems in browsers you don't support. So at least you can get an understanding of how usable the tool is if in a browser that you don't officially support. Then compatibility with current and future technologies, and I really, again here, mean what technologies you're using, the technology stack that you're using. Automated testing tools do have a lot of nuance in how they work with different tools. For example, Justin was up here earlier talking about Storybook. Storybook's compatibility with Angular is decent, but not as good as it could be, right? So understanding the compatibility that tools have with the technology that you're using. A lot of tools are built either by the teams whose technology you're using, especially when we're talking about core front-end technologies like Angular or React or other ones. So a lot of tools were built by these teams or are modified and managed specifically by these teams to have high integration. And so you want to understand how difficult the integration is between the tool and your chosen technology, and how many features that tool supports with your chosen technology. And again, this really does matter. There is a wide variety of integration difficulties and feature set compatibility. So a tool might list a bunch of things, but with Angular, it might not support all of them, or with React, it might not support all of them. And then future technologies, again, if you have a good solid idea of what technologies you're going to be moving to, then understanding whether or not it's going to be compatible with those is also important. Then reliability, which flakiness, false positives, this one is critical. This is, I think, one of the ones where managers can really have a direct effect. And that is understanding how many times a given tool produces false positives. In the end-to-end testing world, especially with the web, this is a real problem that tools will frequently give back false positives. A tool that is notorious for this is called Selenium, which happens to be certainly the most popular end-to-end testing tool in existence, right? And Selenium is notorious for giving back false positives for a variety of reasons. Some of this is how we build our software, how software itself is actually built, and some of the inherent nature of how Selenium works with our product, and some of the inherent nature of the web. You combine those three things together and you have these tools that get kind of flaky, and it's kind of the boy who cried wolf syndrome here, right? There is a critical measure where a certain amount of flakiness and false positives, the end result is that the engineering team will begin to ignore those negative results. And now what you have is something that has only a net negative effect on your product. If the engineers will no longer use the tool, then and yet it still exists in the pipeline, in the chain, then what you have is this thing that only pulls down your velocity and adds nothing, because when there is an actual failure that exists, nobody believes the tool. And so high levels of flakiness are really important to understand, and as a leader, you can have an influence on hearing that your team is saying this tool is too flaky, and understanding that they may not surface to you that they don't trust the tool and they aren't using it, because there's this sort of like, they feel like there's a mandate, we have to use it. And so behind the leadership's back, and I'm as guilty as this, I speak to this because I have done this. Behind leadership's back, we just ignore the tool, right? Or worse, we'll go in and fix the tests, so they stop giving false positives, but they also stop giving accurate positives as well. So now we have this tool that simply looks like it's being implemented, but it's not actually in use. And that can go on behind your back if, depending on the culture and what's going on. So understanding the flakiness and being open to it. And if a tool is that flaky that the team is not going to use it, then be realistic, right? Address that issue. Target users. Tools will target different levels of users. So a tool might target developers, and that might be the typical automated testing tool that we think of, is this is going to be implemented by developers. But tools can also target QA individuals. So these two types of tools tend to have high levels of programmability, right? Usually, for developer tools, they're almost always just an API interface, and the developers have to write code in order to use the tool. For QA, it can vary a little bit, but generally QA targeted tools also have a high level programmability, And generally, the UI and the ability to interface with the tool through an existing user interface that the tool exposes is very low. But there are tools who target the product team, leadership, right? Non-programmers, essentially. And these tools can be very useful for leadership because they can allow you to do things or other, let's say, less expensive resources to implement automated testing so that you can still improve the quality of the code that you're shipping without necessarily dragging down or utilizing resources you don't have, right? Devoting too many development resources, or if you don't have a large QA team, needing to, well, we don't have people to do this, so we can't implement this. But instead, you can enable non-QA, non-engineering people to actually write tests. And there are tools that do this as well. So understanding who the tool is targeted at is very important. So let's talk a little bit about the categories that automated testing tools fall into. There are unit testing tools. And for those who aren't familiar with what unit testing is, that's when we just test a little tiny piece of the software, right? We're not actually testing the software as a whole. We have end-to-end testing tools that typically leadership gets a little bit more familiar with because those are the tools that test that does the app actually work as we want it to. And then finally next we have visual testing tools, right? And these tools work by taking actually like screenshots of our application. And these tools are unique in that they can expose to us issues that are nearly impossible to detect otherwise through your typical unit and end-to-end testing. For example, was there a small CSS change that still the correctness of the application worked, but now something that is important is no longer visible, or is less accessible now, or off-screen, or too small, too big? Did the colors change inappropriately and now our application looks wrong, especially in corners of the application that aren't often hit, right? So these visual testing tools can be really important as well. And then finally, performance tools, as I mentioned before. So these are the things, I want to talk specifically about several testing tools that it's important for you to be aware of. And again, I'm going to frame this we're talking about web applications, and I'm going to be fairly Angular specific here. If you're not doing web or you're not necessarily Angular specific, this information is still applicable, but this is really for if you're doing Angular applications on the web, this is the really important stuff. So underneath the unit testing tool section, these are the unit testing tools that you should be aware of and know them by name. None of them. Because your engineering team, this will, if they test, this is something that they are intimately opinionated about. In the Angular world, there's only really a couple of options anyway, but trust them to use the tool that's best for them. You don't need to, if you were a contractor, you don't need to know what brand of hammer that your people like to buy, right? It's less important for you to understand which unit testing tool. Just to note, what is important though, is to know that there is a unit testing tool being used and that your developers, your engineering team is doing unit testing. So that, I just said something that may or may not be evoking some shame in the room right now. It is not uncommon to not be doing unit testing or any kind of testing at all. There are a lot of projects that do that. As much as we go to conferences and we hear people like me talking about how important testing is, yet we still can be in a space where we haven't done it for any of a number of reasons. How many people here are working on a product that started as a prototype? And that prototype was meant to be scrapped and rewritten in the real thing, but we just took the prototype and kept using it. Only 1, 2, 3, 4, oh, now we got. All of a sudden people are being honest, right? Aaron Frost and I, when we met, we worked on a product that actually started out that way. And it was super awesome. We were super happy with all the design choices that were made because everybody said, hey, well, the people before us, we're told this tool will not be used. We just need a prototype in order to show customers. We'll build the real thing after we get customers interested and prove the concepts. And then it was, well, why don't we take the prototype and do it because we're so far along. So you need to know that testing is being done. If testing isn't being done, I'm going to talk at the end about strategies in order to introduce testing or improve the testing that you're doing. But unit testing is something that should not be ignored. No aspect of testing should necessarily be ignored, and unit testing is one of those. If your development team isn't doing unit testing, then it is time to start working on how do we introduce unit testing to our development team. Again, I'll talk a little bit about that, but that's something that deserves its own talk. End-to-end testing. So here I'm going to actually list a couple of specific tools. The first one is Cypress. Okay? So this is a tool that you're probably not using. It's a relatively new tool. It's been around for a little while, but it's actually a really exciting tool. So if your team is not either aware of Cypress, if they're doing end-to-end testing, but they don't feel like it's okay for them to look at and evaluate other tools, and you can have an influence on that, then influence them to take some time and evaluate Cypress. Cypress is a really exciting testing tool because it enables the developers in a way that the other alternative tools, Selenium-based tools and a few others, can't, and can actually significantly impact the velocity of what you're doing on an end-to-end through the way that this tool actually works. And it deserves its own talk to really explain why that is, but just understand that this is a tool that you should at least be aware of. I'm not saying go and implement it. I'm just saying it's certainly something to bring up and have a discussion and have people say, we can't implement it, we don't want to implement it, we are considering it, whatever, but just to be aware of it because what it's doing is fairly novel and revolutionary right now. It has its own drawbacks and weaknesses. Okay? It doesn't have wide browser support, but again, it enables things in a way that is pretty revolutionary. So it's something I do want you to be aware of. Browser Stack. This is one you may already know the name of. What's great about Browser Stack and important is that it's great about testing your application. You're running your end-to-end tests that run the entire application, running them across a wide multitude of browsers and a wide variety of devices. And when it comes right down to it, yes, desktop browsers we started to see this kind of place where, for the most part, they all kind of work the same. But mobile is still back what desktop browsers were 10 years ago, right? There still can be a big difference on different aspect ratios. You know, every phone seems to have a slightly different pixel count than every other phone. And so understanding whether or not your application is actually really working well, especially if you have an application that can be accessed on mobile, which as most web applications will be accessed primarily on mobile. Understanding that. So Browser Stack is something you should be aware of if you're not aware of it already. Then recorded tools. I mentioned specifically Mabel here. I'm not endorsing Mabel in any way, shape, or form. Just as an example, there are plenty of others. What scares me about Mabel is if you want to find out how much it is, you have to ask. And so if you have to ask it, you can't afford it. It is a paid product, but there are others out there, and this is an example of one of those tools that could be used by the product team. Okay, so you could go in and write tests that do this, 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 and this. If you're in that situation where you're actually not doing tests, something because whatever the political reason is, something like Mabel can enable you to test because now you can do it, right? Or you can have an administrative assistant can do it. Just about anybody is enabled to write these kinds of tests. So these are for end-to-end tests, but that's something to be aware of as these types of tools. So even though I specifically mentioned Mabel, I'm not endorsing that against its competitors, but some tool like Mabel. Performance testing tools. So Perfume.js is definitely one you should be aware of. There are others. The Angular team actually built one called Benchpress, but Perfume.js seems to be what the industry is sort of in love with at the time. So if you're not doing performance testing, utilizing Perfume.js can actually be a fairly straightforward thing to do, and you could start doing some performance testing and incorporating that into your testing strategy. And then Lighthouse CI. Aaron's talk about Lighthouse was great. You can actually incorporate that into your CI platform. So instead of just you running it yourself and saying, hey, this is red, I don't want it to be red, you can actually incorporate it into your build chain and even deny builds based on a Lighthouse score that's too low. Then for visual tools, again, I'm going to mention one specifically, Percy, even though there are a wide range of tools that do visual testing that compare a screenshot before and after the current build and then tell you if something has changed. There's a lot of those. I've just mentioned Percy specifically because it's a fairly popular one used with Angular. But there are other tools, and I don't necessarily specifically endorse Percy, although I think Jesse endorses Percy. Is that right? Jesse endorses, so there you go. All right. So I want to finish up by talking about testing improvement strategies, how to improve the amount of testing that you're doing on your team. So the very, 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 very best strategy you possibly can do is to write the tests first. Right? The reason that this is the best strategy is because if you write the tests first, then there's never tests that don't get written. Right? And if we want to make use of something, we want to do it. How do you save? You put your money away first. Right? So this is exactly the same thing. Write the tests before the code. And this is called, we often hear the term test-driven development, but from an entire testing standpoint, it's behavior-driven development is what the actual term is, because of behavior-driven development, we start with an end-to-end test that says the entire application should do this. And then within that, the developers will end up going and writing unit tests first and then writing their actual code. Although you don't actually even have to do that. I've got a little diagram here for what BDD is. So feature tests meaning end-to-end tests, right? We write a failing feature test, and then in order to get that feature to work, we then usually go in and do test-driven development and write little tests to make the code work. But that aspect can actually be skipped, but instead we could just write the failing feature test. We have this, we want a feature to do this, and then when the feature is finally implemented, if we're not doing unit testing, or our development team really doesn't want to write the tests first, they want to write the tests after, and you can't get them to change their minds, but you can do your feature tests first. And that way you have good feature test coverage of your code. So this is called BDD. You can research it more. So a good question to ask is, who writes your behavior tests? And as I talked about that before, right? Product team can write the behavior tests using certain tools. There's other tools like Cucumber and Pickle that let you write tests with sort of in English. It's still kind of logic-based. You're still kind of coding, rather than Mabel's a recorded one where it records what you do as you go act around, move through your website. But there are other tests that are other tools that allow you to sort of write it in a logic-based but English. I kind of already talked about those tools, Pickle and Cucumber. So alternative strategies. If you can't write the tests first, here's your alternative strategies, and these are the various stages. We start at stage one. Stage one is we just write tests for bugs. We have a bug, we write a test for it. Right? So if you're not doing any testing of any kind, and you just want your lowest barrier to entry to tests, this is it. Outside of maybe just you taking it on yourself or your team taking it on, not the engineering team taking it on, but just write tests when a bug is encountered. Okay? Write a test to make sure that bug doesn't crop back up. Regression bugs are a really common form of bug, so this stops regression bugs. Next, the next level down is we do that and we write tests for any new functionality we write, but we don't worry about any of the existing functionality. The next level down, we write tests for anything that we actually touch, right? Even if we're not actually writing new functionality, if we're writing new functionality and that system interacts with some other system, we write tests around both of those things. Then the next level down is we selectively test high usage. So we go through and we say, what are our critical features? We're going to start adding tests on those, and now we're devoting time in our sprints in order to do this. We might put 1 or 2 or 3 resources on, you're just writing the tests for our high important stuff this sprint. And then finally, your 5th level, which is a complete test coverage plan. We're going to sit down, we're going to map out everything. We're going to get through it in the X number of days, weeks, months, years, and we're going to have our application fully tested. This is your final strategy. So I'm going to skip my next slide because that was an accident slide. And finish up with this one, which is, thank you very much. I appreciate your time. Again, my name is Joe. If you're looking for any training for your team, that's what we do now, is we do training through Thinkster.io, and you can use the code AngularConnect in order to get a discount for your team. But I really appreciate your time to talk to you about something that I am very passionate about. I really love testing, and I like to see tests improve and teams improve, and the value and that comes out of testing is really, truly immeasurable. So thank you very much.